Welcome to another home delivery from the Ars Electronica Center. My name is Birgit Hartinger, and today I'm speaking to you from the main gallery from an exhibition part called Global Shift. And today I'm going to introduce the Copernicus program from the ESA, European Space Agency. At the moment, 7 satellites are part of this Copernicus program, but the whole program is not only the satellite imagery, but also so-called in situ measurements. In situ is on-the-ground measurements, and part of it is also the emergency management system, which I'm going to show you at the table on the other side. We are standing in front of an elevation model of Upper Austria. You can maybe make out the lakes and Linz in the upper right corner, and down here are the Alps. This is not totally natural. It was measured with Sentinel I, but the heights are twice as high as the plane, which means the Alps are not quite as peaky as they appear in this elevation model, but it looks more dramatic. It was measured with a Sentinel I, which is a radar satellite, and radar satellites are used not only for elevation models, but also to monitor avalanches, floods, and the advantage is radar penetrates the clouds, so you can also get imagery if there are quite a lot of clouds, or also in the night. Radar is an active system, means a ping is going out and returning back to the satellites, which is used to measure. And if you want to measure changes, you lay 2 radar imageries above each other. This is called an interferogram. And with this, you could measure subsidence or floods or the change of the landscape after an earthquake. But I'm going to point out what Sentinel I does over at the screen, where you can see it a little bit better. At the moment, Sentinel I A and 1B are in orbit. They a little below 800 kilometers height, and it takes them a little more than 100 minutes to complete one orbit. Because of the success of this pairs of satellites, Sentinel 1C and 1D are already commissioned, and it was said that they should be launched in 2020. At the moment, if you look at the website, you get to be announced, so they should go up pretty soon. Okay, the next pair of satellites are Sentinel II. Again, A and B are in orbit. Again, they are in a low Earth orbit below 800 kilometers, and it takes them again 104 minutes to complete one orbit. Sentinel II does high resolution images, and it does it in 13 different channels. So if you look at those clouds up here, this is at the moment a channel combination in the visible range, but if I change it to an infrared channel along with 2 visible channels, you can see that the clouds are in the same position. And if I change the image again, now we have a thermal image, and it is the same picture, just channels are used which are not visible to the human eye. And as you can see, you get the glaciers in blue. So you can determine what is a cloud. Clouds are still white, but the glaciers are of course cooler than the clouds, and so they are blue in this image. If we would have a wildfire in there, it would be bright orange. But that's a thing we're going to show on the other side. So this was Sentinel I and Sentinel II, but there is also a pair of Sentinel III satellites, and we're going to look at those and at Sentinel I on the screens on the wall. So what you can see here is another radar image, a Sentinel I image. Radar land reflects very well in radar. So those white things are land parts, and this is the sea. And why was this image taken? If you look up here, there was a ship which had a collision, and oil was spilling out from the ship. In this case, it was an accident, but in the last years, it was very popular among sea captains if they if they transported oil into a port. Afterwards, they went to the sea and washed their oil tanks with seawater to save the money for having them cleaned in the port. But this is illegal, of course, and with the Sentinel-2 satellites, Josef Aschbacher, the director of ESA Earth Observation, announced in a talk 2017 that in the last 2 years, so 2016 to 2017, they were able to reduce the oil pollution of the Mediterranean Sea by 2/3, which is quite a lot. So it's used for environmental things also, and it's not only crude oil which is being washed out, but before Gibraltar, they found an oil film in the sea which was palm oil. And another use for the radar is EMS, and the only example we have here is a radar image from China. Wait a moment, I'm going over here. Here you see the river system before the flood, and then if I pull the layer over here, you see it after the flood. It's hard to find out the flooded parts with the naked eye, so an artificial intelligence was used to point out the flooded areas. We don't have an example here, but EMS, the emergency management system, uses an artificial intelligence also to calculate where a flood will appear in a few hours, because we know the landscape and we know how much water is there, and we know it's flowing downstream. So the emergency management system can then warn, for example, a city to prepare to be flooded in 5 hours or a day in advance. The emergency management system does it automatically without being asked for all members of the ESA or the European Union. This is an example from China. Other countries have to pay for the data from the emergency management system, or in case of developing countries, often the United Nations asks the emergency management system to help out. That was, for example, done with a tsunami in Palau a few years ago. So those were examples from Sentinel-1, and now we are turning to Sentinel-3. Sentinel-3 there's a pair up there, 3A and 3B, and it does only medium ranged images. When I talk to my visitors, I always tell them if Sentinel II does an image of Paris, then Sentinel III takes an image of all of France. And where it takes the Sentinel II, the pair of them, around a little more than 5 days to complete the imagery of the whole Earth. It takes Sentinel III, a satellite, only a little more than 1 day to take pictures of the whole Earth. There's in the background, you see a picture of California done by Sentinel III. And at the moment, it's almost natural, but the changes, now it's natural. This is not natural, as you can make out. Sentinel III does images in 35 different channels. And this enables this pair of satellites to take measurements in of temperature measurements up to below 0.3 degrees, which is very, very accurate, because if you hold 2 thermometers up in the air, you will have more difference than 0.3 degrees. Above this image of California is another, the last satellite which I'm going to describe, Sentinel 5P. 5P for precessor, because this is kind of a test satellite with a completely new instrument called Tropomi. And with the Tropomi instrument, they can measure particles, nitrogen oxides, sulfur dioxide, carbon monoxide, not carbon dioxide, formaldehyde, and ozone. And here you see the particles from a wildfire in California in 2018. But if you watch the news at the moment, you will know that there are raging wildfires in California right now. And with this Sentinel 5P, they were able to track those particles. And because of the wind direction, they crossed the total continent of North America and the Atlantic. And right now, today and yesterday, the bright orange sunrises and sunsets in Europe are due to particles in the air from the wildfires of California. I said you can do measurements. They use Sentinel III also for measurements of the sea temperature, which is rather important for if you want to know about El Nino or La Nina, or the colder water after the wake of a hurricane. This video, which is running now, is at the moment at the year 2012. Sentinel III was not in orbit then, so if you watch the video for longer, which we are not able to do right now, you'll see that after 2060 the measurements are much more precise. That was when this satellite went up. And again, here you see a video of the sea temperatures and how they run. And here, for example, you see the Gulf Stream coming up. And we noticed with those measurements that the Gulf Stream is slowing down. It will never stop completely because of the Coriolis forces, which makes that spin. But if the temperature rises that much and there is no ice in the polar regions anymore, it won't flow up all the way through up to Norway, but it will curl down and go to the American coast, which means that places like the Netherlands or the UK will have the same temperature like Newfoundland on the other side of the Atlantic Ocean. Okay, so those are the five, at the moment 7 satellites, 4 different types. There will be Sentinel I and Sentinel VII in the future, but they are not yet launched. And what I also need to mention, all this Copernicus data is available for free for everyone, because it's also used as a booster for the economy, the European economy. You can download only 2 sets of data if you are just a normal user, but if you want to provide a service using the satellite imagery, you need more than 2 sets of data. You need a high-speed line, and one requirement for companies using the satellite data is they have to be situated in Europe. That's why Silicon Valley is banging on the door of the ESA at the moment. And you at home can also download the data from all satellites using a scientific data hub. If you're interested in that, just check out the ESA Copernicus site, or sign up on Facebook to ESA or the Copernicus system. With this, I'm ending today's presentation, but I'm going to announce that we are going to take a closer look at false color images tomorrow. Wait a moment, that's the different, wrong direction. Here, there is false color images of Vesuvius. Those are false color images done by Sentinel II, and tomorrow I'm going to explain how they are done and what they are used for. Tomorrow in German, on Friday in English. So thank you for your attention, and I hope to see you again soon.